Professor Raymond Kim, or you can just call me Ray. I teach ITP 308, which if you're BME, I'm pretty sure you're required to take it as one of your CAD courses. We teach SolidWorks in that course, but today we're actually going to be talking about CAD principles in general and how those ideas, those principles actually transcend any particular CAD package. We're actually going to be working with Fusion 360, which I like to a certain degree better than SolidWorks, mostly because it runs on any platform. We'll talk about getting started in Fusion 360. We'll talk about the document itself, how we navigate the document, and then we'll talk about creating our first couple pieces. Today, we're going to work on doing, let's see if I can share my screen. Can you enable share screen for me?
Okay, I think it should be good now.
All right. So today we're going to be working on making this thing. This is Mjolnir. Mjolnir is Thor's hammer from Avengers. Typically, I'd like to, introduce projects and stuff that people would actually be interested in. I'm sure no one really cares about bearing housings or pump actuators. So we're going to do something a little fun. I got the inspiration for this off of some images. You can just Google these images. They look something like this. And so just kind of taking a look at what we want to get to towards the end of this workshop. Hopefully we can get there. If not, then we'll get as far as we possibly can. Okay. So a little bit of background about me. I've been teaching at ITP for about 7 years now. I teach mostly in CAD and programming. And we actually started a new class called ITP 228, which is rapid prototyping, which leverages 3D printing technology. If you can see behind me here, we have our SLA printer. Along with CAD principles, so half a semester CAD, half a semester 3D printing to create product prototypes quickly using 3D printing. If you're interested in that, let's have a chat afterwards. But let's first introduce our working environment. This is Fusion 360, which is cross-platform, and you can do it Mac, Windows. I don't know about Linux. But one of the things that I like about this is that I can collaborate with a bunch of people. So if you're planning on attending the ASBME Makeathon, highly suggest you go with Fusion 360. It allows for cross collaboration with a bunch of people very easily. Second is all the data stored in the cloud by default. And so if I need to make changes to a file, well, then those changes will propagate to all the people that I collaborate with without me having to share a link. Finally, it also allows for version control. Version control just allows me to see who edited and when. For example, if you take a look here in my workshop folder, I've got Mjolnir here. I'm currently on version 3, meaning this is the 3rd time that this thing has been saved. If I click that, I can actually roll back to previous versions. Version 1, nothing was there. Version 2, just the top, the hammer here. Version 3, final body, all done. So I can promote any one of these and see who's been touching stuff. Super, super important. Okay. Now let's actually get into the design. But before we do that, let's create a new design project. So I'm going to create a new design. This is what we're going to see when we open up Fusion 360. I hope that all of you are following along at home. Open it up. This is our design space here. Inside the design space, we actually have several different workflows. Up here in the top left corner, if I choose design, this is me creating the solid model. Generative design is something that we're using AI and machine learning to generate the parameters of the design, which is something that Autodesk has recently introduced and has really been pushing, where instead of you actually coming up with the design parameters, you just set the parameters of the design. It has to do X, Y, and Z, is constrained by this geometry, and let Fusion 360 do it itself. Some render tools, animation tools, simulation, manufacturing, all those great things. So a lot of great stuff right here in the design document itself. We don't have to switch our file. So let's stick here in design. First thing that we need to take a note of is all the way at the bottom, there's this thing called the timeline. Yes, just like in SolidWorks, things that we do are dependent upon when we do them. And so certain things won't propagate if we decide to roll back in the timeline, just like in the Avengers. Okay? Inside of this document, we can create assemblies, components, and bodies. Those are typically the 3 things that we can create. An assembly is defined as more than one component or body. A component is defined as more than one body or one or more bodies. And a body is just one continuous solid piece of mass. right? So whatever we do, we can create assemblies, components, and bodies. Other things that I can change about the document itself at this level here in the document settings is change units. Now at any time I can choose any unit I want. It doesn't really matter. This just says this is going to be the default units. Okay. Lastly, before we actually start doing stuff, take a look in this top right corner here. This is my view control. I can drag my cube around to change the positioning of my views. I can click on any one of these faces, for example, a front face, and it's going to lock to normal to that face, or I'm going to look right onto that. Okay. So that's basically what's going to happen. All the design stuff is going to happen inside of this graphics area here. Every once in a while, we'll get a little pop-up window, probably somewhere over here, that's going to allow us to change certain parameters of certain things, and we'll discuss those when we get there. But the first thing that I always encourage you to do in Fusion 360 is to create what's called a component. A component, again, is just a collection of one or more solid bodies. And the reason why we like designing components rather than just starting off with bodies and just hoping that the bodies work themselves out is because with a component, we can create something called a joint. For those of you who've done SolidWorks before, SolidWorks works in assemblies. An assembly uses mates to reference two parts to show you how they come together. In Fusion 360, we call these things joints. But in order to create a joint, you need at least one component. And so we'll create a component right here from the get-go with nothing in our graphics area. Here in our solid design tab, we'll click on assemble. We'll click on this icon here, new component. This is that little pop-up window I was telling you about. Can everyone see this? Cool. Standard components or sheet metal components, we're working standard components now. This will be an internal component, meaning it'll belong to the document. I'll give it a name. We'll call this Mjolnir. Now, right now, we don't have any solid bodies. This is just empty three-dimensional space. So from bodies, doesn't make sense for us. If we had bodies, we can then use those bodies to create components. The parent is where does this component live inside? Currently, this is the top level document selected. So it lives in this document. And then finally, activate, meaning make this the component that I will currently be editing. So only one thing changed in our document browser over here, and that's that I've added this component Mjolnir. Inside of this component here, I've got the origin folder, which defines the origin as well as all the different axes, X, Y, Z, and all the different planes, X, Y, X, Z, and Y, Z. Okay. Now, we actually have to start doing stuff. And the doing stuff always starts off with a sketch. Sketch is two-dimensional. And so if we want to sketch something that is two-dimensional, the first thing we need to select is the plane on which to sketch. You can imagine you're about to literally draw something. In order for you to draw something, you need a flat surface on which to draw. As of right now, the only flat surfaces I have are this plane, and this plane. Front plane, right plane, and the top plane. So we'll select one of those planes. And what we'll be designing, at least right now, is we're going to design basically the main body. And so if I take a look at what this is here, I'm going to design this piece in blue. I'm not going to do these end caps here, well, because we'll worry about those in a second feature. I'm going to design just this main body here, not including this little cap at the top, not including that, not even including these little chamfers here on the side or anything down here, and then forget the handle for now. Okay. Now, this is the methodology of design. This methodology of design essentially breaks it down into its simplest components. We want to think of the simplest geometry, get that geometry on the page, and then as soon as we get that geometry on the page, start chipping away at it to make it look like what we need it to look like. And so for right now, we're going to be focused on this middle part here. Now, this middle part here is essentially just a square. I'm going to take that square, and then I'm going to expand it into this loaf. So let's start with a square, and then let's expand it. When we expand it, we'll talk about the tools For expansions, we call those things extrusions. Okay. So let's jump back here. Let's select one of these planes to draw our square. Now I'm going to select this plane here and call this plane the right plane, and I'm going to draw the square. So I select this plane here. In my solid create tab here, I'm going to choose create sketch, or I can right click on it if I want to, and then create sketch. There's a lot of different shortcuts that you can use in Fusion 360. If you've worked in SolidWorks before, a lot of those shortcuts don't transfer over. So please excuse me if I use some shortcuts. If you have any questions, please feel free, just shout them out. Right. Now, I chose that plane. I hit the sketch button, which then drops us into our sketching interface. In this sketch interface, I've got these create stuff here. I've got some modify stuff here. I've got some constraint stuff here. And we'll talk about all those things in turn. The first thing we want to do is be able to draw a square. So let's draw a square. I'm going to go to my create. If I click on the drop down, all this does is show me all of my create tools. So I'll choose, if you notice, there's no option here for square. And that's because a square is essentially just a rectangle with some special features. And so a lot of this is going to actually have you really think about what geometry taught us back in high school. Right? So a square is a rectangle, so I'll choose a rectangle tool. You'll notice that there are 3 different types of rectangle tools. Now, there's a method for 3 different types of rectangle tools. I'll tell you that the first tool, the 2-point, and the last tool, center rectangle, can only create rectangles that are horizontal or vertical. If that's what we want, then I'd select one of those 2. If I want to create a rectangle at any angle, for example, here, or like this, or even horizontal, well, then I'll choose a 3-point. And so definitely matters which one you select because it'll affect what you can do. Now I'm going to choose center rectangle. A center rectangle is given by a center point and then one of the corner points. And I'm going to put the center point right here at this point. This point here is defined as the origin. Origin here is actually a projection of the real origin, which is a 3-dimensional origin, onto a 2-dimensional plane. So I selected the 2 points, the center point, and then I drag out and I select the end point there, and that creates for me my rectangle. Now, this rectangle is still just a rectangle, but it needs to be a square. There are 2 ways that we can do this. I'll show you the first way. The first way is to add a dimension to 2 sides, not 4 sides. And I'll show you why not 4 sides. I'm going to take any one of these corners and I'm going to drag it. You'll notice that no matter how I drag this, it keeps its rectangular shape, meaning its rectangular relation. Both sides, the left and the right side of the rectangle, stay the same length. Both top and bottom also stay the same length. And if you'll notice, this rectangle can't rotate. So now all I really have to do is give a dimension to this side and give a dimension to that side. Now, based on these drawings here, I found that the square dimensions should be 3 by 3. Now, if you want to scale up your Mjolnir to whatever size you want, you just take the final dimensions and you multiply it by whatever scale you want. So if you want it 200% scale, you multiply all the final dimensions by 2. And so let's add some dimensions. Keyboard shortcut here is D, or you go up to your create tool, and then right here at the far right is dimensions. So I'm going to give this a dimension of 3 inches. So I'm going to do 3, and then I'm going to do IN. Now I don't have to do IN. IN is the abbreviation for inches. If I want this in 3 millimeters, then I would just do MM. And so this is the reason why the document units don't really matter, because I can drop any dimension I want at any time, so long as I specify the units. If I don't want to specify the units, and I don't, because I hate it, then I'll just drop the number. The number then assumes the document units, which in this case is inches, and so 3 becomes 3 inches. Now I'll do the same thing for the top. And again, just drop a 3 there, it makes it 3 inches. Everything good so far? Awesome. Now let's take this square and then let's bring it into the 3rd dimension. And the way that we'll bring it into the third dimension is through a process called extrusion. Now, extrusion can happen in several different forms. And the result of an extrusion can take on several different final effects. We'll talk about each of them as we get through. I'll introduce them, but I won't tell you or show you what they do just yet. Right? So let's take this square and let's extrude it out. Now, again, we want to take a look at what it is we're trying to do. We're trying to do this middle portion here. And so if I think about what's happening, I've got my square here, and then I want to extrude it. And I want to extrude it this way, a certain depth, so let's call it D, and then this way, also the same depth, D. And so the final depth, which we'll call capital D, is equal to 2 of these. Now, it just so happens, again, I did the measurements, that the final depth of this particular one is 3.5. And again, you can scale it up however you want. That's 3.5 inches. If you want it to be a 7-inch Mjolnir, which is about yay big, then you just multiply all dimensions by 2. So the big D, which is the full length, is 3.5. 3.5, whatever you want it to be. Okay? So let's take this sketch, which actually is right here in the middle, and let's expand it out, little d this way, little d this way, to a total depth of 2d, or 3.5. And the way that we'll do that, we'll go ahead and go to our solid tab. Sketch tab here is everything two-dimensional. Let's move to our solid tab here, and let's click on extrude. Extrude is now going to say you've got this profile. This profile is determined to be what's called a closed profile. Closed profile, if you can imagine, is you take our sketch lines and you start at one point, you start drawing your line, keep going, keep going, keep going, and then finally you meet up with the starting point, which creates a closed area. And that's exactly what we've got going on with our square here. Square is this way, this way, this way, and this way. Closed area. So we're going to take that profile and now we're going to extrude it. This is where this dialog box really starts to show its power. First thing we can select is profiles. Notice profiles plural. So if I want to do multiple profiles all at the same time, I absolutely can. We've only got one selected because we've only got one area, which is the square area. And then I get to select where I want to start from. I can start from where I sketched it, which is the right plane. I can say, hey, start from some other place, a certain distance away, or I can even say start at an object. Now, we'll cover this a little bit later. Right now, I just want to say profile plane. The direction now is going to specify one direction, two directions, or mid-plane or symmetric. One direction is one side, two sides, both sides, and I can change them independent. And then finally, symmetric. We want to do symmetric. Whatever I add to this side, I will also add to this side in equal quantity. I get to determine how far. So how do I want to measure this? I'll give a distance value here, which we know to be 3.5. And then because I'm doing it symmetric, there's two ways of measuring that symmetry, either by the half length, which would be the little d, or by the full length, which would be capital D. We'll do the full length, and we'll make it 3.5. As soon as that happens, bam, 3.5 full distance, which makes both sides 1.75 in depth. The last thing is the operation. This is where we start to see the different effects. Currently, we've got new body selected. New body says this thing is going to be its own separate body. The other operations are join, which means take this and add it to some existing body where they intersect. Cut, which is take this and cut away from an existing body. Intersect, which is wherever this intersects with an existing body, keep only the intersection. And the last two are new body and new component. We don't want to create a new component. We want to work in this specific component, but at any time we can just as easily say this is something brand new. So I'm going to keep new body. So there it is, our 3-inch by 3-inch by 3.5-inch cube. Now that we've got this cube, we can actually use the geometry of this cube. And so let's go back to our Mjolnir. This is that original cube. And now what we want to do is create this side cap. Now, if I rotate this side cap, you can see the side profile. This was our original cube profile, right? That was our 3 by 3. And then there's this smaller square here, like that. And so what if we create another sketch that just contains this smaller square? Now, I'm not going to rotate back, but what we're going to see is this is the edge of our existing cube. And our smaller square is going to be somewhere out here. And so what we need to do is we need to say, I need a sketch out here. But I don't have a flat surface out here. I've only got flat surfaces here on the actual cube and those 3 original planes. And so how do I get something out here? And the answer is going to be that we're going to create what's called a reference plane or reference geometry. Here we are. This is our original cube. I want to be able to sketch my square somewhere out here. And so I don't have a plane or a face that's out there. And so I'll create one. And so up in my solid tab, I'm going to go to construction geometry, which is given right here. I can construct 3 types of geometry: plane, an axis, or a point, also called a vertex. Now, the method by which I can create this is given by references, meaning what am I going to use to define this plane, this axis, or this vertex? Now, if I think about what I need to do, what I need is I need this face, but I need that face somewhere out here. And so I need to offset this face a certain distance away from it to create this imaginary plane on which I can sketch. And so I'll go to my construction geometry here. I'll choose offset plane, which allows me to select a distance away. The plane I'll select will be this plane here. I'll choose distance to measure the distance. And that distance is going to be measured as 0.75 inches. And so it's going to create this offset plane, 0.75 inches away from this face. This type of geometry is going to be super useful for defining surfaces on which to sketch that don't already exist. And this would be one of those instances. I want to create a sketch on a plane or a surface that doesn't already exist. So we'll use what's called an offset plane. Let's sketch on this plane now. I'll go to my sketch tool here. I'll select this face. Now I'm sketching here. Again, we'll do our square. We'll use our center rectangle. We'll choose the center like that. So there's our square roughly. Now, the length of this square is going to be 2 by 2. Now we saw previously that I can just dimension this and dimension that to both be 2. But one of the other things that I can add are things called constraints. Constraints are geometric constraints. Now again, this requires that we understand very thoroughly geometry of lines. What does it mean for certain things to be in certain relationships or constraints? If you take a look at these lines, they actually already have some constraints applied, given by these symbols here. And so this symbol here is the parallel constraint. This parallel constraint is constraining this top line and this bottom line. Now, if we think about the adjacent sides, sorry, not the adjacent, the opposite sides of a rectangle, well, those lines are definitely parallel. So that jives with what this relationship is telling us. We've got another parallel relationship here between the 2 left and right sides. Again, that jives with what we know about rectangles. Finally, we've got this relationship here, which is perpendicular. I can't select, hold on. This one here, which is perpendicular. Perpendicular constraint in that corner just means that all the angles are 90 degrees. Now I don't need perpendicular everywhere. I only have one perpendicular relationship between this top line and this line to the left. I don't need one here, I don't need one here, and I don't need one here. Even though we know that they should be perpendicular, we don't actually have to say it. And so those three perpendiculars are implied constraints. We never have to say it because the combination of the other constraints actually makes it so. There's one more constraint here that's keeping this rectangle horizontally oriented, and that is this one here, which is the horizontal vertical constraint. Now we say horizontal vertical constraint because they actually act as one constraint. This one is the one that I hate the most. And the reason why I hate this the most is because if I want to draw a line, let's say I draw this line and I apply the horizontal vertical constraint to this line, it's going to make it either horizontal or vertical based on whether it's closer to being horizontal or closer to being vertical. So if I click on this, it makes it horizontal because it was closer to being horizontal than it was vertical. I hate it because that's not a good way to think about this. Now, regardless of how I feel, what's left to do is add an extra constraint to make this a square. What differentiates a square and a rectangle? A square is a rectangle with one extra constraint, and that is that all sides are equal. So I'm going to apply this equal constraint here. Now, I'm not going to apply it to this top one and this bottom one because that doesn't make sense. They're already equal. I'm going to apply it to this one and this one. Adjacent sides. Now, again, I'm only going to apply it one time. When I apply it one time, notice that it affects the entire square all the time. Didn't need to do it to the other two. So we'll leave it at that. Finally, I still need a dimension, so we'll drop a dimension here. Again, our dimension was 2. So there is our sketch. You can see it there and there. Now, here's something a little strange. What we need to do is we need to go from this big square to this little square. That is what we see here. And so I've got this big square here. I need to join it with this little square by drawing the lines from the corner points. Just like that. A little exaggerated, but that's the effect we're going for. Now, this is kind of a more advanced feature, but we'll still show it nonetheless. We're going to call this thing a loft. A loft allows me to transition between two profiles that are not the same, whether they are different in scale or even different in geometry. Loft allows us to go between the two of them. And so I'll choose loft. I'll choose the profiles, this profile and this profile. And we can see that it's going to try to join them up edge to edge or corner to corner. That's exactly what we wanted to see. We'll say, okay. Before we do, the operation here is going to be join. We now have a body. And so anything that we do with this body should be to add to this body. So we call this the join operation. We're adding this material to the existing body. Join. Okay. So it looks like it's coming together. We've got this side here. No problems. Now there actually will be a problem. And it's right here. This is called a chamfer. What a chamfer is, as you can imagine, you've got the edge of a table here. A chamfer just slices the edge off so that you have no sharp point like that. Now, the way that chamfers are applied is I can specify the distance to cut. But if you'll notice up here, the distance to cut is some distance, let's call this D1. And then here, the distance to cut is some different distance, D2. And so what it looks like is this edge, which I'll use a different color, red, is longer than this edge. And so that's not going to work for us. We need the chamfer to actually taper. And so all we're going to do is we're going to change something about the feature, meaning something about this body here, and then something about the sketch so that we can achieve this using a loft. So we did something bad, well, not necessarily bad. We did something incorrect. Now, how do I undo what I just did? The answer is go to the timeline. Timeline is down here. And so all I'm going to do is I'm going to reverse the timeline. I'm going to undo what I did. The first thing I'm going to do is the loft. So the loft is gone. The sketch is still there. I'm going to undo the sketch so that I'm not affecting the sketch. And so if I look down here, the things still exist. The sketch still exists. The loft still exists. It's just we've rolled back the time to a point in time where they don't currently exist. At this time, whatever we do here will be injected into the timeline at this point. And so we've rolled back time. We're going to start doing stuff in the past, which will then propagate into the future. Right? So the first thing that we're going to do is we're going to chamfer this. Meaning we're going to cut off these sharp edges. So here in my modify, I'm going to click on chamfer. And the things I'm going to select are going to be these edges, this one. I'm going to roll around, this one, and this one. And so I'm selecting the 4 edges of this box that are going to be cut. Now the chamfer distance is going to be of equal distance on both sides. So essentially we're going to cut it at a 45-degree angle. And I'm going to cut it 0.75 divided by 2. Notice here in the value for the chamfer distance, I wrote an expression because I don't want to figure out what 0.75 divided by 2 is. And so instead, I'll just write 0.75 divided by 2, and I'll let Fusion figure out what that value is. And so if I don't know a value, but I know the equation for the value, then I can just type in the equation, and it'll solve it for me. And so that's going to be my chamfer. And so you'll notice that the result here is basically a square with the corners cut off at 45 degrees, so that this distance here is 0.75 divided by 2. Again, don't know what that value is, but I don't care to know. Now I'm done here. This was where I wanted to be. So what I'm going to do is I'm going to roll forward, but I'm not going to roll forward to the loft. I'm just going to roll forward to the sketch. And so the loft still hasn't happened. We're going to focus now on the sketch. We're going to do the chamfer to the sketch, but we can't do a chamfer to a sketch using the chamfer tool. Chamfer tool only works on solid bodies. A sketch is not a solid body. So let's go into our sketch. Let's edit our sketch, and let's go ahead and basically just cut off the corners. And I'm going to cut off the corners by drawing some extra lines. There to there. And so this line now represents where I'm going to cut. Now the distance I'm going to cut, meaning this distance here, is going to be 0.25 divided by 2. And so again, let's use my dimension tool. Let's dimension these two entities. Let's do 0.25 divided by 2. There it is. Now I need to apply the same idea here. And then here. And then here. Now I can do the same thing. I mean, I can draw the same line, do the dimensions, like blah, 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 do all of that. Or I can make use of symmetry. Symmetry is going to be your best friend when you're trying to do a lot of stuff. And so here in the sketch level, we're going to do a sketch symmetry. And so we're going to use our mirror tool. I'm going to take this thing and I'm going to pretend like there's a mirror such that its reflection will show up right over here in the exact spot that it needs to be. All I need to do is figure out where that mirror is going to go. Now, if you're looking at this, well, if this line were to represent the mirror, well, then I mirror this across that line, I get my resultant over here. So here in my mirror tool, select the things to mirror in objects, this guy, the mirror line, this piece. You'll see that my mirror shows up here. There it is. Now, if I want to take these two pieces and mirror them so that they're here, well, I have to now draw another mirror line. There's no mirror line that currently exists. And so I'll draw a mirror line. That mirror line will go like this. And so this line, if I mirror this across this line, goes here. If I mirror this across this line, goes here. Now, I'm going to create this line as what's called a construction line. A construction line is the dotted line. The dotted line doesn't break up my areas. You notice now the dotted line doesn't divide my thing into two rectangles. Again, I'm going to choose my mirror tool. Nope, not you. Nope, not you. Stop. You and you. Those are the things I'm going to mirror. My mirror line is here, and then my two other lines show up there. So there they are. Now I've got this and this. And those were the two profiles I wanted. I wanted my square with the corners cut off here, and then I wanted my square with the corners cut off here. Now I can roll forward on my loft. Finish my sketch. Roll forward on my loft. Now, it didn't quite create the geometry. And the reason is because it's using the wrong profile up here. So let's edit the loft. So down in my timeline, I'll right click on my loft, click on edit feature, and then I'll just go to one of these two profiles, in this case, profile 2, and change it. So first profile, second profile. Okay. And so this is the geometry we wanted. We wanted to see this chamfer taper down to a smaller edge. Now, the way that we did that was by chamfering the first, and then in the second sketch, chamfering the edges using lines to get the right depth. So we've created basically 2/3 of the general shape. Now, again, we want to take this idea of we did one side. I don't want to do the exact same thing on the other side, meaning I don't want to have to create the reference plane, don't want to have to create the sketch with the square, and then cut off the corners of the square, and then perform the loft. What we want to do is we want to take this thing that we already did and then just do it again on the other side. Right? As engineers, we need to find the quickest way to get the same results. There's an extra caveat that we need to do it in the safest way possible. But for right now, we're not affecting anything, so quickest way possible absolutely works for us. We're going to apply the same idea of what we did in the sketch level to the feature level. And again, it's just going to be mirroring. Now, we're working in 3 dimensions, so when we talk about a mirror, the mirror tool is going to need a plane, not a line. In the sketch, it's a line. In 3 dimensions, it's a plane. And so go to my Create tab, click down here on Mirror. What am I going to mirror? I'm going to mirror features. Features are the things that we did here in our Create tab. We can also select faces, bodies, or components. Don't want to do bodies because I'm not mirroring a body, though we could. Don't want to do faces because I'm doing more than just a face. I'm doing something that actually adds mass. Features. Objects to mirror. I'm going down here in my timeline. I'm going to select that last loft we did as the object, and then the mirror plane. The mirror plane is this plane somewhere on the inside here. But notice that no matter what I do, I can't select it, right? Why? Because it's actually buried inside of Mjolnir. So if I want to select it, I have to like cut open Mjolnir and look at it. Two ways I can solve this problem. One, I can just go to my origin folder here and select it. It's this one, the YZ plane. Or two, I know that it's in there, I can see it. I'm just gonna long click. Long click is to click and hold. So I'm gonna click and hold, which is going to open up the depth folder. The depth folder allows me to choose any object, basically from top level all the way through. I don't want this face, I want this, the YZ plane. And so just by clicking and holding, I open up the depth folder, which allows me to choose objects that are buried inside or things essentially that I can't select. That's what I want. And this is going to be the result. So basic shape, pretty much done. Okay. Any questions so far? No? All right, let's keep trucking on then. How much time do we have? Anybody?
About 15 minutes.
15 minutes? All right, let's blast through this. All right, so the next thing we want to do is I want to go up top here and create that circle thing, right? The very top of Mjolnir is that circle thing. So we go to the top here, again, sketch tool. Draw our circle. Our circle is going to be centered here in the top base. Draw our circle, drop our dimension. This dimension here is going to be 2 in diameter. And then we're going to extrude this bad boy a certain distance. So from the profile plane, one direction, a certain distance. So that distance is going to be 0.0625, I believe. What did I write down? Yeah. 0.0625. Again, my operation is going to be join so that it joins the rest of the geometry. And there it is. Now, I kind of want to get through some other stuff here. Reference geometry. And that is, I kind of want to show you what I did for these things. You take a look at these things. Basically, this handle extrudes down, and then this thing actually wraps around it to provide some form of grip. Now, I'm not going to show you in the other one, but I'll show you what I did here. I'm going to roll back. So after we created the top of this, I just extruded this handle all the way down. And then all I said was, well, I need essentially to draw on the handle these little curved things. Now these curved things you see have a little, dip there. And so I couldn't just draw a circle around it because that wasn't complex enough. I need something that went up this way and then down this way and then around. And so I created something called a surface. A surface is an infinitely thin sheet of paper that I can bend and shape in any direction that I want. And so this is the surface that passes through it. The way that I created this surface is by using a surface sweep, which is actually a product of 2 different sketches. This sketch and this sketch. And so I take this U sketch or this parabola sketch and I sweep it along this, which then eventually creates this surface. And then what I'm going to do is use where this surface intersects with this body and use it to draw that line. And so we do what's called a split. Split face here just says wherever the surface intersects this body, draw the line, and that's going to be the line that's being drawn. And so you can imagine on this curved surface, I'm just going in and literally drawing this line. What I'm going to do with this line then is I'm going to take a circle given by this sketch, and I'm going to take this circle, I'm going to run it all the way along this line. I'm going to do what's called a sweep. This sweep then creates this kind of circular bead that then intersects with the body. Once we have that, all that's left to do is to propagate this same thing all the way down the handle. Again, we're lazy, so speed and efficiency. I'm going to create a linear pattern using this patterning tool here, rectangular pattern, and I'm going to pattern this sweep all the way down the handle. Last couple things I want to show you, which I think are kind of cool, is we need to create the pommel. The pommel is just this thing right here. Now, if you notice, it's kind of weird shaped. And so what we're going to do is we're going to create the most basic shape. The most basic shape is just cylinder. After we do the cylinder, we're going to cut away part of the cylinder, this part, and this part, to get just what's left over. Now, I can't cut the cylinder and not cut in this handle. Right? If I take the cylinder and I add it together and then I cut it, I'll also cut away at this handle part. We don't want that. So a little trick is to create this pommel as a separate body, cut just the pommel, leaving the handle intact, and then join the two back together. So let's take a look at how we can achieve that. Again, I'm just going to roll forward here. Oh, sorry, there's some other stuff in between. There. Here I created this thing, which is going to be the body later. But when I did the extrusion, you'll notice I now have two bodies. I have this body and this body, two separate bodies. So the question of when would you ever want two separate bodies is going to be answered here in a second. Now, notice these two bodies actually overlap. You'll notice body one, which is the main body, actually falls inside of this second body, which is going to be the pommel. Now, that's okay for now. What we're going to do then is now create this sketch. This sketch here is going to determine how we cut the pommel. And so I want my pommel to have this kind of shape at the end. And so when I do this extrusion, I'm going to do a cut because it's going to remove material. But in my objects to cut, I'm not going to select body one. Because now I've got two bodies to contend with, I can actually select which bodies this feature is going to interact with. And so if I select body one and body two, well, then it cuts both of them and leaves that gap. Again, that's not what we wanted. We wanted to only cut the second body, the pommel body, and leave the main handle alone. And so that's what we see here. The main handle is unaffected by this cut. And so the pommel body gets cut, main body is left alone. That's why we would use multi-body parts. Now, the last thing is to go in and say, no, these are not two separate bodies. Let's combine them back into one single solid body. Up here in my modified tab, I'll choose my combine tool. This combine tool will then say, hey, we've got these bodies that are overlapping each other. How do you want to contend with them? And essentially what we're going to do is a join of our bodies and join them together. Last little bit of that. And so now we've only got one solid body to contend with, top of the hammer, plus the handle, plus all of these pieces here around the handle, and then the pommel, again, all together in one solid body. Now, the last thing is to make it look cool, because who wants Mjolnir just looking gray? And so the last thing we're going to add is appearances. And so I'll right click basically anywhere here or in my create tab. Oh, sorry, in my modified tab, I'll click on appearance. Now, appearances come in many different forms. They come in materials as well as sheens. And so, for example, if I want the whole body to be chrome plated, shiny chrome, I'll go ahead and go open up metal, inside chrome, take chrome, and just drop it in here. Yeah, remove all the other ones. There we go. There's Mjolnir looking shiny. Now, some other things that I can apply is I can apply these appearances to select faces, meaning not the whole thing, but actually places that are very specific. For example, these pieces in between here are all wood. Stop selecting stuff. The worst UI tool ever. There we go. So I select just this face. I can go here. I've selected walnut, and I'll just drop it in here, and then this becomes the body. Sorry, my Chrome is taking over. Everywhere. Chrome. Oh, my appearances library failed. Oh, that sucks. Let's roll back. No? All right. Well, my appearances library is apparently failing, but the idea here is that we can take these different appearances and apply them to different faces. And so it makes it look like we've got different materials on these different components, although in reality, this is still one continuous solid body. So if I wanted the top here to be a different shiny metal, I could do chrome. If I wanted each of these individual faces here to be wood, I can apply a wood of a certain type. They've got all kinds of woods here. Bamboo. If you want other things, you can just download them from the Fusion 360 library. If I want these pieces here to be, let's say, silver, I can do that as well. And then finally change the pommel body. I know that we're running short on time. I know this is kind of a big sprint towards the finish line. If you're interested in doing this model, let me know. I can give you all the relevant dimensions, as well as walk you through how you can create this. But the ideas of CAD, again, transcend whatever environment you're working in. You have to be able to think first in 2 dimensions, and then finally be able to figure out what it's going to look like in 3 before you actually get to 3. And so you have to be able to hold the object in your mind visually before you can actually see it occur, because if there's a disjunct between what happened and what you imagined to happen, then you need to figure out why the software isn't doing what you want it to do. I apologize. I wish we had more time. I thought this was kind of a cool project, but hopefully we can do more of these seminars in the future. But thank you all for coming. I know it's getting late and you all have other things to do, study for stuff and things like that. So I appreciate you allowing me to come here and give you, an hour of my time. And I hope that I see you all eventually at some point. I've seen some of you already in my 308 course. So thank you again.
Thank you so much, Professor Kim, for that great workshop and, for taking your time out of your evening today for going through that with us. And thank you all for attending as well. I'm going to stick around if you have any questions, I guess, for the last minute. Also, if you guys want access to this recording and you sign up for the Makeathon, we will be releasing that recording to you guys on the first day of the event. But if you want access to it before then, or you didn't sign up for the Makeathon, make sure to email Advaita directly to get a link sent to the recording. I'm just going to go ahead and drop her email in the chat for that. But yeah, thank you, everyone. Have a great evening.
Hey, Professor Kim.
Hey, Dominique.
How are you doing?
I'm good. Surviving.
Surviving.
Yeah.
How's teaching?